So today, as we continue our basic review of our derivative rules, today we're taking a look at, as you can tell, the product rule. The product rule. And unlike limits, the product rule for derivatives is a little more complicated. You might recall that with limits, we could just if we had the limit of a multiplier, like if we had the limit of two things multiplied together, we could just take the limit of each separately and multiply the answers together. Here, it's a little more complicated. There's actually quite a bit. There's a couple more steps in order to find the derivative of a product rule. So if we want to find the derivative of some value u times another value v, we take the first value, and we multiply it by the derivative of the second value, and then we add it to the second value times the derivative of the first value. Now, you might have seen this in different ways. You might have seen this organized in different ways, but I like to look at it this way because it helps me remember. If I associate, if I am able to associate it with a 1 and a 2, then I realize, okay, it's the first times the second times the derivative of the second, the first times the second prime, plus the second times the first prime. It's easier for me to go, okay, it's the power rule, or the product rule is the first times the derivative of the second plus the second times the derivative of the first. That's an easy way for me to remember the product rule. But you might have seen it in a different way. But again, with multiplication, commutative properties, and addition commutative properties, this could be rewritten in multiple ways. That's just the way I just decided to show it to you guys. But enough of me rambling. Again, this is the basic stuff. Let's get right into our practice problem of the day. I'm going to, again, differentiate in red like I always do. So we're going to find the derivative when f prime of x is equal to that. And so, as you notice, we have two things multiplied together, so we're going to be using the product rule. And I'm going to actually I'm going to write the answer in red, but then I'm going to actually take the derivative using the colors I used for the first and second. So we have the first, which is just 3x minus 5, times the derivative of the second, and the derivative of the second. This is the sum. The derivative of the sum is the sum of the derivatives. So we're going to have a 4, bring the 4 down, x, subtract 1 from the power, 4x cubed, plus 8, and the 1 is just a constant, so it's just going to go to 0. But we're not done. Plus the second, so everything in the second, x to the 4th plus 8x minus 1 times the derivative of the first. The derivative of 3x is just 3, and 5 is a constant, so that's it. If we end up simplifying this, we're going to get f prime of x is equal to, this is a FOIL method, so I see a 12x to the 4th. Outside, that's going to be plus 24. I'm going to do the inside first. That's going to be negative 20x cubed. Then I'm going to do the plus 24x minus 40. And then here I'm just going to distribute the 3 through, plus 3x to the 4th plus 24x minus 3. And if we were to simplify this, f prime of x would be, I see a 15x to the 4th, just one of the x cubed powers, so 20x cubed, plus 48x, right? So I got my 4 power, my 3 power, my 1 power, and it looks like it's just the minus 43 that's left over, and that is how to use the product rule to take a derivative.